Hello everybody. So this is your homework question video that you asked about. We see the number 25 and number 49 that we did in class. You guys asked for number 17 and 75 for the video, so I'll go ahead and do those two. So number 17, find the derivative of the function. We have well, this one could have been done just without even the chain rule here. That one definitely could have been done. Oh, unless, okay, I see. So there's actually two ways that this one could be done. You could use the quotient rule, and then you wouldn't have to do any chain rule there. Or you can rewrite this as x minus 2 to the negative 1 power, and then that one would use the chain rule. Since it's a chain rule unit, I'll go ahead and do it that way. Alright, so number 17, let's see, y equals 1 over x minus 2. Again, as I said, we can rewrite that as x minus 2 to the negative 1 power. And so when we do the derivative, we take the derivative of the outside, which is the power there of negative 1. So negative 1 comes down, and then that would be x minus 2. Negative 1 minus 1 is negative 2. And then we take the derivative of the inside, which is just 1, because we just have x there. Make sure I'm remembering that correctly. Yes. Okay. And so then to simplify that, the 1's can multiply, and we have y prime equals negative 1, and then the negative 2 power can bring it back down, x minus 2 squared. And that would be the derivative. Again, that could have been done with the quotient property or quotient rule, with you having a numerator and a denominator. All right, let's see. Number 75. All right, so number 75, let's read our instructions. It says, find an equation of the tangent line to the graph of f at the given point. All right. We have our function, we have our point, looks good. Use a graphing utility to graph the function and its tangent line at the point. Okay, we can plug that into our calculators or Desmos. And then it says use the derivative feature of the graphing utility to confirm your result. All right, I'll show you something really nice with Desmos, and then I still need to show you the derivative feature in our calculator, so we'll do that at a later date, but I'll show you a really easy way to do the derivative of using Desmos. So number 75, we have f of x equals square root of 2x squared minus 7, and we're going to be at the point 4, 5. We want to know what the tangent line is. So first off, we need to know what our derivative is. So f prime, oh, before I even do the derivative, I see a square root, so I want to rewrite that first. So that's going to be 2x squared minus 7 to the 1/2 power. So now, doing the derivative of the outside is going to be the power there, so bring that down. 2x squared minus 7, and that'll be negative 1/2. And then I multiply that by the derivative of the inside, which should be just 4x. If I simplify that, that should be, let's see, what is in the numerator? That'd be 4x over 2 times this to the 1/2 power, or the square root of 2x squared minus 7. All right, we want to find the tangent line at 4, 5. So I need to know what is f prime of 4. Well, that would be 4 times 4 over 2, and then 2 times 4 squared minus 7. So that would be 16 over 2. Let's see, 16 times 2 is 32, so square root of 32 minus 7. Which is 25. Well, that works out very nicely. 16 over 2 square root of 25 should be 16 over 10. Or what would that be, 4/5? No, 8/5. Divided by 2, yep, 8/5. So then we can go ahead and write the tangent line. So that'd be y minus y1 equals m times x minus x1. So that'd be y minus 5 equals 8/5 x minus 4. There we go. All right, so let's go ahead and throw that into Desmos and see what we have. They want us to graph our original function and the tangent line, I do believe. Find an equation of the tangent line, use the graphing utility to graph the function and its tangent line at the point. Desmos. All right, nice thing about Desmos, let me actually change this to this, see it a little better. So if I have f of x, and that is the square root of 2x squared minus 7, so square root of 2x squared minus 7. Oh, forgot an equal sign. That might be useful there. Oh, there we go. Very nice. So we have our graph right there. We have the point at 4, 5. Parentheses 4, 5. There it is. All right, and then we had our tangent line, y minus 5, I believe, equals 8/5 equals 8/5 x minus 4. And there it is. That looks pretty spot on. If I zoom in, we can see that that is definitely our tangent line at that point. Now, the problem is asking us to look at finding the derivative. So we found that the derivative of that function was 8/5. Nice thing in Desmos, remember one way we can write our derivatives is as f prime, and Desmos recognizes that. So f prime of x, I can actually do f prime of x, and it will graph the derivative function there, which is really nice. But I can also plug in the x value that I'm looking at, which is 4. And that's 1.6. I can change that to a fraction here, 8/5, which is what we found, 8/5. Now another really cool thing with Desmos, that 5 is the y value of f at 4. So I can actually write, if I turn this one off, this is really cool. So y minus f prime, no, not f prime, this is just f of 4, my y value there, equals the slopes f prime of 4 times x minus 4. And there we have the exact same tangent line, see, right on top of each other, which is really pretty cool. And again, this is using the function notation and the derivative feature of Desmos. You can do something very similar to that in your graphing calculators. Actually, there is a derivative feature. If you want to start looking for it, you can, but that is problem number 75. All right. Let's see, where was that? That was right here. There we go. There's our work. And why don't I go ahead and put this graph into there. So let's see. Let me actually do this snipping tool. Go ahead and kind of do all of this. And there we go. Pretty cool stuff. Go ahead and put that in right here. There we go. All right, and so that pretty much concludes what we have there. Thank you for watching.